So this is just a short video about the basics of scientific reports. A few things to know about scientific reports. They're usually very structured and they follow quite a precise structure as well that we'll go through. The language in them should be precise. You should be clear about what conclusions you're drawing. You should be clear about what you're pointing out to the reader, as you'll often be dealing with quite complex information, so it needs to be clear. They should be concise. So they should be concise both in terms of your sentences and paragraphs and the word choices you use, and also the overall length, because you could be dealing with an awful lot of data, a lot of background information. So you need to filter that to present to your reader exactly the amount of information they need to understand what you did, why you did it, and what conclusions you've drawn. And also they are factual, as they're usually based on something that you've done, be that an experiment or a study, so you're actually dealing with real world stuff and facts that you need to present. So the normal structure include these elements. So you've got an abstract, which it starts with, an introduction, materials and methods, a results section and a discussion. I'll actually deal with the abstract at the end for reasons that I'll come to. What's important to know is that these elements should tell a kind of story of your study or experiment. So leaving the abstract aside for 1 second, roughly you've got the introduction that's saying what you were going to do and why you were going to do it. The materials and methods is how you were going to do it. The results are what you found out, and the discussion is why that's important. A good introduction should give a background to the topic. So it should show how your study is going to fit into the overall area, that you understand why the topic as a whole is important, that you also understand how people writing within the topic are talking about the topic and how you're situating your study with regards to theirs as well. So it should, moving on from that, highlight why you're doing the study. So why is it important? How are you adding to knowledge in any way? You should also define any important terms. So any specific terms that you're using, any particularly technical terms. That's more in terms of even if a reader who's familiar roughly with your subject area might not understand those particular terms, they're the kinds of things that you do need to define. And it should also evaluate previous work done in the area. So that kind of links to highlighting why you're doing the study. So you might find somebody who's done work in a very similar area to you, but you may feel that you're able to add to what they did in some way, in which case you need to say how you're going to do that and evaluate what they did as well. So roughly, a good structure for an introduction looks something like this. So at the start of the introduction, you might have the broad issues. So an overall overview of the topic as a whole, why it's important at the moment, the main trends within it. That might be the point at which you define any important terms as well. Then you might move into studies which overlap with yours but aren't exactly the same. So maybe things which are a similar kind of experiment or study but perhaps in a slightly different but related area, or something which is in the same area but you know that they used a very different methodology to yours. Then you might move on to the studies which are more directly relevant. So these are the ones which are far nearer to the area that you're studying, but things where you feel that you can update what they did or add to what they did, or essentially studies which are in a similar area where you can explore gaps in what the knowledge is, where you can put your own experimental study into that to show how you're adding to the knowledge generally. Also, very importantly, by the end of your introduction, it should be clear what your research is, and it should be clear what the aims of your research are going to be, so what your research questions are. So generally, the end of the introduction is your research aims and questions. That moves straight into your materials and methods section. So the materials and methods section is essentially the bit where you go through how you did it. That gives somebody the opportunity to come and check that what you've done was done in the correct manner, it was done fairly, it was done with the correct methodology, there was no way that you could have been biased, for example. So there's a few things to think about with that. First of all, materials and methods, because you're describing something that you did, it's usually in the past tense. So you would write that you poured beaker A into beaker B and heated it to 100 degrees. you wouldn't say you will pour beaker A into beaker B and heat it to 100 degrees, so you do it in the past. So it should be a clear account of how the experiment or study was carried out. Importantly though, it should be written for a competent audience. So if you imagine you writing for one of your peers who didn't do the same experiment, that gives you a good idea of the level that you're sort of aiming at. So for example, it should have details of important equipment. So things where you've made a deliberate decision to use one piece of equipment rather than another, but not excessive detail. So there could be a large piece of equipment where you've got a choice of two and you might have to make a decision over which one you use, in which case you would include that. But you might not include things like what type of beaker you used or what type of Bunsen burner, because they're all pretty generic. So probably the best way of getting you to think about this is for you to read these two examples. So you can pause the video at this point, have a read of the first example, have a read of the second example and decide which one you think is better. As you can see, the first example is probably not the best example. It's just too much detail. So for example, we've got things like saying that the blue button was pressed to zero the machine. Well, if you're competent, you'd do that anyway. Or saying things like the green button was pressed to read the absorbance. Again, if you're competent, you would do that. We don't necessarily need to know it's a plastic cuvette, for example, because that's probably pretty standard. So things like that are going a little bit too far. The second one, however, is much better. It does include things like the Genway spectrophotometer, because that's a big piece of equipment. You may have had to make a decision on which one to use. It says that all experiments were performed in triplicate rather than going through it each time. We just assumed it repeated it the same. It gives a certain amount of detail about allowing things to incubate for 1 minute, but it doesn't keep going through that. So basically, if somebody had reasonable lab skills, they could read the second one and they could do what you did. So the results section and the discussion can be quite tricky, because sometimes they're tricky for people to pull apart. It's quite important to remember that the results section is basically for just showing what your results are, but not interpreting them. So as I've said here, a good results section should highlight main findings. So it is filtering out the data, presenting it in a way that somebody can understand, so whether that's putting it into tables or graphs or diagrams. It should point out unexpected results, so things that you weren't expecting to happen, outliers that might be important, things like that. It does need to present the results concisely as well, so you need to think about the amount of data that you've got and what you actually really need to put in there. So in fact, for example, if you half ran the experiment and then had to stop because something went completely wrong and you knew all those results were basically rubbish and you started again, you don't necessarily put the rubbish results in. So you basically just restart the experiment. What you don't want to do though is interpret the results. So it's presenting them, showing what's important, but without saying why that's important quite yet. One thing to think about is also the presentation of the data itself. So making sure things like your graphs and your diagrams are clear. So I've got an example here of some good and not so good graphs. So you might want to pause it for a second and just take a quick look. So as you can see, the graphs on the left hand side are quite confusing. There's lots of grid lines. The legend that shows you what bar is what series is sort of stuck in the middle of the graph and is quite difficult to see because of the grid lines, and also because they've used sort of lines to colour in the bars as well. If we're meant to be comparing the top and the bottom graphs, for that one on the left hand side, the axes are actually different on the y-axis as well, so one's 9 and one's 120, so it makes it look like they're almost equivalent when they're actually quite different sets of results. The ones on the right, however, you can see that they both go up to 120, so it's much easier to compare the two. The series are actually labelled just directly under the bars, so it makes it a lot easier to work out which is which. It also means they've not had to colour it in different crazy colours. Also, the axes are labelled as well, which they weren't in the other ones, so we weren't really sure what we were looking at. And they've got rid of the grid lines, which might have been a bit confusing too. So, a good discussion section. This is the point at which you do interpret your results. So you'll say which the most important were, you'll relate them back to your research questions and your aims and say how much they actually help you prove or disprove what you were looking for. You might identify any shortcomings in the research, so anything that did go wrong, anything you identified as a problem with the methodology that could be addressed. That might lead into as well further research. So there may be unexpected results, you're not sure why they happened. That is absolutely fine, but you need to point that out, say what you could do in the future to kind of investigate that. You also need to relate the findings back to the research or subject area, which I'll go into in a minute when we look at the structure. And also, obviously, you need to draw conclusions. So why is this important? How is it helping you find new knowledge? What's it added to what we already know? So this is quite a good structure for discussion, so it's by Hoffman. And as you can see as well, it's almost the opposite of your introduction. So you basically start on your initial interpretations and your key findings. You go back to your research aims and objectives and questions, say how you've answered them, put in the supporting evidence. Then you might widen it out a little bit to making comparisons or contrasts to previous studies, going through your unexpected findings and the further kind of research you may do. So you kind of widen it out a little bit into more than just your research questions. And then you kind of come back out to a summary and also the significance or the implications. So that's your kind of end point. You're kind of almost thinking back to the wider subject area and thinking about how your study fits into that again, how you've added to the wider subject area. So, although that's the end of the report, you've got one last thing to write, which is actually your abstract. Now, I won't go into much detail here because there will be further help in this package as well on abstracts specifically. But one thing I will say is that you cannot write the abstract until you've written the report. The reason being, a good abstract should sum up the article from start to finish. So it's got a bit of the introduction, your materials and methods, your results, and also your conclusions in it and your discussion. It does, however, need to be concise. It needs to point out the absolute most important points that are in each of those sections, and as I just said, it needs to be written last. So if you do need help with that though, have a look at the section on abstracts that will be in this package on Blackboard. Also, if you need any further help and support, our details are there as well. So that's just the end of this quick video.